really quick video. So we're supposed to identify what transformation here, and that's all you have to do. And then determine if the two shapes, the original and the image, are congruent or similar. So first of all, let me just go over these pictures, and you can tell just by looking that they're all the same size, exactly the same size. Doesn't seem like they have any dilation, so no. So I'm just going to start off by saying everything, all the shapes here from 1 to 20 are congruent, so we don't have to worry about any that are similar. Okay, so first shape, notice that the points this on the black quadrilateral here. If you look at point Q, it's written like this, and if you look at this point over here, it's written Q is an apostrophe, and we call that Q prime. That's a way of distinguishing which one is the original and which one is the image, right? So the original one is this guy, and the image is the one that has the one on the bottom. Okay, so what happened to this one? Well, if you look at the shape, if it was a translation, right, and let me just draw the shape somewhere over here. If this had been a translation, all a translation does, right, is move this shape around like this. Right, that's all it is, from left and right, up and down, but it keeps everything else the same. Now notice that if I took this shape and put it on top, they are not exactly in the same direction, right? So it was not a translation. Is it a reflection? Well, no, it's not a reflection as well, right? So the only other possible is that this is a rotation. So Matt, look, let me point Q right now is aiming this way, and then point Q on the bottom one is aiming that way. So obviously it's been turned, so this shape was turned, or better yet, it was a rotation. Okay, this one, we have our original, which is right over here, right, the original figure. And notice that I can take that original figure and just slide. I think somebody said the word slide, and we slide it to the right. So a slide to the right, or a movement, so a movement that goes up and down and or left and right, it's called a, well, you can use the word slide, but the word that we want was a translation. Look at this shape over here, and then let me outline it as best as I can. So again, take this shape, it looked like it moved to the right a little bit, and then somebody brought it down. Look at that. Is it a rotation? No, it's not a rotation. Okay, not a rotation. So this is also a translation. Image 4, let's do 4 over here. And then over 4 is right here, and then let me outline right here. So we had something like this, another quadrilateral, something, a fish-shaped figure with 4 sides. And if I take this and move it and bring it down, look, so somebody took this shape, moved it to left, and then brought it down, look. So that is a translation. This particular shape, the next one. Okay, look where point K is pointing. All right, so imagine this was a pencil. Point K is aiming this way, and now point K is aiming that way. So this is a, and if you want to think about it, and let me use this one. This is a, oops, not this one. How do I spin this? This one? Yeah. No. This one. No. This one. Yeah. No. Also no. Oh, I should be able to rotate this. No. Well, it's a rotation. I don't know why I can't rotate it. Weird. I used to be able to rotate this, but this is a rotation. So I could take that and rotate it so that so I would rotate it this way, right? And if you rotate, this is coming down, 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 and then the K points up. So this is a rotation. Why can't I move this? Anyways, this one. Now, if I draw this line and I tell you that this is the line of reflection, right, the mirror, think about this. If you're standing over here, that's you standing. Your image on the other side of that mirror would be right here. Obviously, that's not it. So it's not a reflection because look, the person F is standing over here. His image is over here. That is not a reflection. So that's not a reflection. So we can take the image and the mirror. And if it's not a reflection, the only other choice is either a translation or a rotation. Well, it's not a translation because there's no way for you to move this up and down. I'll take this triangle, move it up and down. So it just won't. Right? It's not in the same direction. Right? So it's not a translation, but it is a rotation. And I wish I could rotate this. Oh, I can. Look. Oh, there we go. So if I rotate it, right now, if I rotate this, there. That's a rotation. So let me get back to this one and see if I can rotate this. Show you guys why this is a rotation. So this one, right? So why is this a rotation? Oh, there we go. So if I rotate it, look, right? I'm rotating it. Right? Look, after rotation, it becomes that way. All right, now that I know how to do rotations. Next one. Let me outline the original one. Here's the original shape. And what's being done to it so that it creates a copy image, right? The same image, but somewhere else. Well, it's not a rotation, but this one is easy. It's simply a translation down. So somebody took that image and just said, hey, let's shift it however 6-7 units down. There is the result. Here, let me break that apart. So you have two images. You have an image here, right? The original image that looks like this, right? And then its reflection that looks like that. And really hard to see the cell. So this is point V, the original. Let me write it. So if you tell, that's point V. This is V prime. That's my mirror, right? So you definitely know that this is a reflection because the green triangle, is flipped over. It's flipped over y equals 2, and the result is that red triangle. So that's a reflection. Next one. Let me outline this again with a different color. It's not a reflection. I hope everybody sees that this is not a reflection, right? It's not a translation, but in this case, this is a rotation. Okay. So when you rotate that image, there we go. Sorry, another bit. Right? Rotation. So this one is a rotation. This one, again, this is a reflection. So the first thing I'm going to ask you to do when we get to reflections is, hey, where is that mirror? The mirror is this. That's your mirror. Okay? If you think about that as your mirror, here's person Z standing right here. His image on the other side of the mirror, it's right here. That makes sense. They're both equally distanced from the mirror. Look at point Y. So point Y, look at this guy here, is standing, and he is 1-2 units away from the mirror. His image on the other side of the mirror, it's also 2 units away. And point F, they're both on top of the mirror, so they are, it's just right there. So this is a reflection. This one, ew, okay. It is not a reflection. Okay, so there is, I mean, if you're thinking, hey, is this the line? Is there might reflected over the y-axis? Let me draw the mirror. So think about this. If this is you standing, is this guy here C? Sorry, if this is you standing, this is you. is see this guy here, your image on the other side of the mirror? No, it's not. Okay, and you can clearly tell it's not because A, the distance from that dot to the mirror is not the same on both sides. So this is definitely not a reflection. Is it a translation? Again, no, because the translation is just a movement of the entire shape, right? Left or right, as it is, or up and down. So if I just wish I could make, okay, so here's the original shape, and I'm gonna move it left and right, or up and down, and there you'll see that there is no way I can take that shape, moving it left and right, to be on top of the image. There's just no way. But if I took that, okay, and I rotated it, let's see if I can rotate this. Oh, look at that. Can I get it to be in the image? Look, I can. And then let me just rotate it a little better. So that would be a rotation. Okay, that one's a rotation. Again, this one, it's tricky sometimes to see it, but this is a reflection. Every point, right? Every point has an image on the other side of the line of reflection. So here's your mirror. So think of that. Think of this line here that I'm drawing as your mirror. Gosh, horrible. Can't draw a straight line. There. So imagine this is you, and you're standing in front of the mirror. Look at your image. It's on the other side of the mirror. They match, right? They're same distance away from the mirror. Look at A and W. Person A, he is 1, 2, 3 units from the mirror. A prime is also 3 units from the mirror. Look at Y. It's 1, 2, 3 units away from the mirror. And Y prime is also. So they all match. And then point N, which is right on top of the mirror, its image is also right on top of the mirror. So this is a reflection. There's more. Ooh, there's. Okay, 13. It's a, well, hopefully you have it. It's a rotation. Nah, sorry, it's a translation. If I took this image here, and I simply said, hey, I'm going to take this image and I want you guys to move it, I don't know, 1, 2, 3, 4, 5 units up, and then 1 unit to the right. Look at that. So this is a translation. This looks like a rotation. It looks like a rotation. If I take that triangle and rotate it, let's see if I get that. Rotate it. Oh, look, I'm going to rotate. Okay, and then we're going to talk about a rotation of 90 degrees means that every point shifts 1 quadrant over, either clockwise or counterclockwise. So in this case, okay. So now notice that it either rotates this way, or it could have rotated the long way as well. They end up in the same place. So this was a rotation. This guy here, it's not a reflection. It's not a translation, right? So, I mean, and I can't, it's not as easy as you think to. There we go. So here's a shape. If it was a translation, it meant that I would have told you, hey, let's move this left and right, up and down. And notice that no matter how I move it left or however I move it right or up and down, it will never be in the position of the image that we see. So it's definitely not a translation. Reflection, we can't, if that was reflected over the y-axis, its image would be over here, right? Somewhere over here. That's not it. So it's not a reflection. Is it a rotation? Well, it looks like it's a rotation. So let's rotate it and see if we can see if it's a rotation. So if I rotate it, right? Yep, definitely a rotation. Man, I thought this was going to be a quick video. Definitely not. We don't have any dilations. I don't know why. Here. What's happening to this shape here? Well, this one seems like it was just a translation. So somebody shifted this triangle 1, 2, 3, 4, 5 units up, and then 1, 2, 3, 4, 5, 6 units to the left. There. A translation. This definitely looks like a rotation. Okay. Rotation. So let's see if I rotate that 180 degrees. Yeah, looks like a rotation. Here's my original, right? And then if I take this, well, it's not a rotation, right? It's definitely not a rotation. It's a reflection. So it's not, no, this is just a translation. So somebody took the original triangle and said, hey, move it up a certain amount and move it to the left a certain amount. And that was a translation. Okay. Ooh, what's this? This one, This one's a little tricky. It's a reflection, but your mirror. Let me show you where the mirror is. The line y equals x. Right there. That's your mirror. So imagine that was a mirror, okay, and this was you. Let me put you in red. This was you standing. You're S. Wouldn't your reflection on the other side of the mirror be S prime right here? Make sense? If this was you, G, wouldn't your reflection on the other side of that mirror, represented by the green line, be G prime over here? Okay, and whatever letter that is that I can't see is the same thing, right? The image of this guy would be on this side. So definitely a reflection, but a reflection over the line y equals x, not a reflection over the y-axis or x. We'll get to that. Don't worry. But right now, I just want you to understand or see what type of transformation is happening. So here, last one. Here is my triangle. And I want to see what kind of transformation led to the second triangle. Is it a rotation? Was it a translation? So if it was a translation, it meant that somebody moved it around, left or right, up and down, and there's just no way of that happening. Okay, let me make this line a little better. There's no way of that happening because it just won't happen. There's no way I can take this shape, move it to the left or to the right so that it equals, right, it's in the same position as the blue triangle. It's just not. So it's definitely not a translation. Is it a rotation? Well, let's rotate this. No, 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 no. Keep rotating, keep rotating. No, no. So, again, not a rotation. So the only one, well, it's definitely not a dilation. It's going to get bigger or smaller. So the only other one that's left over is a reflection. But a reflection, where's your mirror? Where was the mirror? So here is your mirror. So imagine I said, hey, let's bring a huge mirror and put the mirror in between, right here. Right, that's your mirror. You know what? Let me use a straight line. I'll tell you that the mirror is this line right here. Right? So now assume that you guys are standing here. So imagine that you're standing here. And that's H. Where would be your image on the other side of that mirror? Well, currently it's 1, 2. So on the other side, 1, 2, H prime, or your image, would be 2 units away from the mirror. So look at G, same thing. They're 2 units away from the green line. T, you're standing right on top of the mirror. Your image is right on top there with you as well. So this is a reflection. not over the y-axis or the x-axis, but over x equals 1. So that's our line of reflection. But don't worry about that right now. I just want you to identify the transformations. Okay. Name 3 types of transformation that will lead to congruence. Well, when it's congruent, everything is the same, right? Clear background, no. Clear grid, no. Clear objects. So transformation of congruence, right? Area stays the same. The side length stays the same. Shape stays the same, right? Everything stays the same, right? So if you started with a little triangle like this, no matter what you did to it, right, it'd still be that same triangle. And if I took one of them, just draw a little further, right? Even if I drew it like that, if I took that triangle, right, and I could rotate it and even bring it on top of it, notice that they'd be exactly the same size. So what are the 3 transformations that you can do? Movements left and right, rotate it, reflect it, and it'd still be the same exact shape. Well, those 3 would be translation, what else? The rotation, and there's one more, reflection. And there's one type of transformation that will do similarity. Similarity, the angle stays the same, are the same, and then the side lengths, and the area change. What's the word that we use in class? Proportionally. Okay. Now let's look at the question. If the shape is dilated to, well, let's pick a shape. Oops, not that shape. So imagine there's a shape, this shape, and you dilate it, and you became twice the size. Well, twice the size. Look there. I hope I'm right. Yeah, twice the size. What will happen? Well, the angles will be twice as large. Well, this is a 90-degree angle. I just made it twice as big. Do you think this angle is now 180 degrees? No. So that's garbage. The angles become half as large. Okay, that doesn't even make sense. This is a 90-degree angle, and if I increase it by twice its size, this angle now become 45 degrees. Also, doesn't make sense. I increased it. This was 90 degrees. Is it still 9 degrees? Yes, it is. So I'm going to draw one more. Even if I made this rectangle here and I said, let's increase everything by, whatever, 4 times the size. Notice that everything except for the angle changed. All right, so let me put some numbers here. Maybe that will make a little sense. So let's say this is what I mean by proportional. I wanted, so let's say this was 1, this was 3. So now if I want to change that, dilate that, right, let's say by a factor of 2, that means I took everybody here and multiplied by 2. So this is no longer 1, it'd be 2. 3, so I dilate by a factor of 2. Dilate this by a factor of 2. It's going to give me 6. So for this one, let's say, I don't know, this is 4. So what did I do? I dilated by a factor of 4. So I'm going to multiply all the sides by 4. And if I multiply 3 times 4, my new rectangle would be 4 by 12. Okay, so, but the side lengths changed, right? The area inside changed. But what's the only thing that that stayed the same? The angles. This angle, all the angles are still 90 degrees. So that didn't change.